Hey everyone! Ready for something super cool? Today, we're exploring the amazing world of digital image processing. It's how your phone makes your selfies look great and how those Instagram filters work. There's a lot of tech behind it, but don't worry, I'll explain it simply. We'll go step by step, and by the end, you'll almost be a digital image processing pro. First, we need a picture, right? Whether it's a breathtaking landscape, a candid moment with friends, or a quick snapshot of your pet doing something adorable, capturing the moment is essential. That's where image acquisition comes in. It's the first step in the process of creating a digital image. This involves capturing the light that reflects off the subject and converting it into a digital signal that can be processed by a computer. Imagine taking a photo with your phone. You point, focus, and click. The camera's sensor captures the light, and in an instant, the image is saved. This process is seamless and almost magical, but there's a lot of technology working behind the scenes. You click, and the camera captures the light. That's image acquisition. The sensor inside the camera detects the light and converts it into an electronic signal. This signal is then processed to form a digital image that you can view, edit, and share. It turns what you see into computer data. It's not just cameras. This data can be stored, manipulated, and transmitted, allowing us to share our moments with others instantly. Scanners do the same, but they use lasers or other cool tech to copy a picture. When you place a photo on a scanner, it uses light to capture the image, converting it into a digital format that can be saved and edited on your computer. So, whether it's a selfie or scanning an old photo, it all starts with image acquisition. This technology allows us to preserve memories, create art, and communicate in ways that were once unimaginable. From the simple act of taking a photo to the complex process of scanning and digitizing images, image acquisition is at the heart of it all. You've got a perfect picture, but there's a little noise. Don't worry, image pre-processing fixes that. It's like a spa treatment for your image. We reduce noise, adjust contrast, and sharpen things. It's like using a filter, but it makes the image itself look better. So before we do the fun stuff, we need to prep our image. Chapter 3. Image segmentation, dividing and conquering. Now things get interesting. In this chapter, we delve into the fascinating world of image segmentation, a crucial step in the field of computer vision and digital image processing. Image segmentation sounds hard, but it's easy. It's like teaching a computer to see and understand the world in a way that's similar to how we do. By breaking down an image into smaller, more manageable parts, we can help the computer make sense of complex visuals. Imagine a picture of fruits. You have apples, oranges, bananas, and grapes all mixed together in a basket. To a computer, this is just a collection of pixels with different colors and intensities. You want the computer to tell apart apples and oranges. Image segmentation does that. It helps the computer identify and separate each fruit by analyzing the different colors, shapes, and textures present in the image. It divides the image into sections, like drawing lines around each object. This process is akin to how we might outline objects in a coloring book, making it easier to distinguish one from another. This lets the computer study each object, which helps with object recognition, which we'll talk about later. By breaking down the image into smaller segments, the computer can focus on each part individually, leading to more accurate analysis and understanding. Segmentation breaks the image into smaller pieces. This is essential for various applications, such as medical imaging, where doctors need to identify and analyze different tissues and organs, or in autonomous vehicles, where the car needs to recognize pedestrians, other vehicles, and obstacles on the road. By mastering image segmentation, we can unlock the full potential of computer vision, enabling machines to interpret and interact with the world in ways that were once thought impossible. So, let's explore the techniques and algorithms that make this all possible. Chapter 4. Image Representation and Description. Talking to computers. We've captured, cleaned, and divided our image. This is the first step in preparing our data for the computer. Each of these steps ensures that the image is in its best form for analysis. Capturing the image involves using cameras or scanners to get a digital version. Cleaning the image means removing any noise or unwanted elements that could interfere with the analysis. Dividing the image might involve segmenting it into different parts or regions of interest. Now we need to explain it to the computer. This is where the real magic happens. We have to translate the visual information into a language that the computer can understand. This process is crucial because computers don't see images the way humans do. They need data, numbers, and patterns to make sense of what they're looking at. That's image representation and description. Computers think in data. They don't see a tree or a car. They see pixels, values, and coordinates. By representing the image in a way that the computer can process, we enable it to perform tasks like recognition, classification, and analysis. This involves breaking down the image into its fundamental components. We turn our image into computer language. This could be binary code, numerical values, or other forms of data representation. The goal is to create a digital version of the image that the computer can manipulate and analyze. This transformation is essential for any further processing or analysis tasks. This could be pixels, colors, shapes, or textures. Each of these elements provides different information about the image. Pixels give us the basic building blocks, colors can indicate different objects or regions, shapes help in identifying structures, and textures can provide details about the surface and material properties. It's like instructions for the computer. Just as a recipe guides a chef, these instructions guide the computer in understanding and processing the image. The more detailed and accurate the instructions, the better the computer can perform its tasks. This is why image representation is so important. You wouldn't describe a painting by just saying, "It's colorful, right?" You'd go into details about the different hues, the brush strokes, and the emotions it evokes. Similarly, when we describe an image to a computer, we need to be detailed and precise. You describe shapes, colors, and feelings. This helps in conveying the full essence of the artwork. For computers, describing an image in detail helps in accurate analysis and understanding. The more information we provide, the better the computer can interpret the image. Image representation is like that. But for computers, it's about giving the computer all the information it needs to understand and work with the image. By breaking down the image into data, we enable the computer to perform complex tasks like object recognition, scene understanding, and even creative tasks like generating new images. Chapter 5. Image recognition and interpretation. The grand finale. This is where it gets mind-blowing. We taught the computer to understand the image. Now let's test it. Image recognition identifies objects. If we show a cat picture, it should say, "That's a cat." Image interpretation goes further. It understands the context. It's like the computer sees the bigger picture. This tech is used in self-driving cars and medical diagnosis. It's like sci-fi.